Welcome to aminacademy.com. In Discrete Mathematics regarding probabilities, let us discuss about independent random variables. In real life, we usually need to deal with more than one random variables. For example, if you study physical characteristics of people in a certain area, you might pick a person at random and then look at his or her weight, height, etc. The weight of the randomly chosen person is one random variable, while his or her height is another one. Not only do we need to study each random variable separately, but also we need to consider if there is a dependence, correlation between them. Is it true that a taller person is more likely to be heavier or not? The issues of dependence between several random variables will be studied in detail later on. But here we would like to talk about the special scenario where two random variables are independent. The concept of independent random variable is very similar to independent events. Remember, two events A and B are independent if we have P of A comma B is equal to P of A into P of B. P of A comma B is P of A and P of B, which is equal P of A intersection B. Similarly, we have the following definition for independent discrete random variables. That is P of x equal to x small x and comma y of y equal to small y is which is equal to P of x equal to x into P of y equal to y for all x and y. Now let us discuss further detail about independent random variables. What is random variable? A variable whose value is unknown or a function that assign values to each of an experiment's outcomes. Independent random variables are variables that are not related to each other, meaning that knowing the value of one provides no information about the value of the other. For example, the outcome of a coin toss is independent of the outcome of a separate coin toss. And the outcome of rolling one die is independent of the outcome of rolling a second die. This lack of relationship means the probability of one variable taking a specific value is unchanged by the value of the other. That means, look at here, you are selecting a ball from one bag and putting in it and take another two balls from these two bags. It is independent event because it is not affected. The first bag is not affected the probability of the second bag selections. That is ball selection from the second bag. Definition of the characteristics. No information exchange. One way to define independence is that the variables convey no information about each other. That means from one bag information is not affect the second bag. So knowing a value of one does not change the probability of distribution of the other. Joint probability. Two random variables x and y are independent if the probability of x being in a set of A and y being in a set of B is the product of their individual probabilities. That is, P of x is element of A and y is an element of B, then which is equal P of x is an element of A into P of y element of B. Joint probability mass function PMF. For discrete variables, independence means the joint PMF is the product of the marginal PMFs for all possible values of the variables. P of x equal to x, comma y equal to y, which is equal to P of x equal to x into P of y equal to y. Joint probability density function PDF. For continuous variables, independence means the joint PDF is the product of the individual PDF. probability density function here, which is f of x comma y is of xy is equal to f of x into y f of y of y. For example, practical example, coin tosses. The outcome of tossing a coin multiple times does not affect the outcome of the subsequent tosses. That means first toss is not affected by the second toss like continuation. Means second toss will not be affected by any other tossing like. The result of the first toss is independent of the second, third and so on. Dice rolls. The number that appears on the first die is independent of the number that appears on the second die. The outcome of one does not influence the other. Sampling. If I randomly sample pumpkins from a farm, the weight of one pumpkin is independent of the weight of the another. So far we discussed about what is discrete in mathematics, what is independent random variables. We have done. Please subscribe our YouTube channel.